Hello guys, welcome back to batch processing part 2. Here basically I'm going to explain how exactly the block size work in batch processing. So in part 1 I have not explained anything about the block size, also a number of record executed in parallelly, or how much parallelism we can achieve using a batch processing, that I have not explained in the part 1. So this part 2 is all about basically kind of complex example. So in basically this XML, I'm going to explain a block. What kind of block? What is a block, and how block size will increase and decrease your performance. So let me show you first. Block size we can configure at batch scope label. This is a batch scope, and block size we can configure. The default value of batch block size is 100. What does it mean? It means that for example, if you provided 100 record to batch processing, and the block size is 100, it is mean that you have only one block created. Okay, in case for example you're providing a like 100 record and you're providing a batch block size is 10, then it means that one block having a 10 record, so there are total 10 blocks are created. Okay, so this is about the block size, and how it will work I will let you know. So in my first example I have payload input payload 1 to 5 as a array. So in each steps you're getting a payload value at a time as 1, another time second, third, fourth and fifth is a payload value. I've also basically add one wait condition here to show you that how exactly our record is processing. Okay, so let me show you use case number 6. So use case number 6 is straightforward. We're providing a record, total 5 records, block size is 100. It means that only one block is created. So let me click on clear logs and use case number 6. So I have created use case number 6. As you can see that we have record number 1, second, third, fourth, fifth, and then we have a on complete phase is executed. Total records are 5. Successful record also 5. So as you can see that our record process sequentially. So it is mean that if one block is created for your batch job, then your thread will pick record one by one because you have only one block. Okay, that's why your records process sequentially: first, second, third, fourth, fifth. Let me show you another example. So in another example, we have a block size 3 and we providing payload as 1 to 10. So one block having a 3 record. Okay, so there are total 4 block. First block having a 3 record, second block having a 3 record, third block having a 3 record, and the fourth block having only 1 record, because we have only total number of record is 10. Okay, so let me show you how exactly the use case number 7 worked. Send. So as you can see that first, fourth, 7, 10 executed at a time, then fifth, second, fifth, 8 executed, and then third, 6, 9 is executed. So what does it mean? So there are 4 blocks is created. So there are 4 blocks created in block first. We have first, fourth, 7, 10. First, 4, 7, 10. No, it is not something like that. Just let me remove that. So we have a 4 block is created. Block number 1, block number second, block number third, block number 4. Okay, so what kind of record we saved in the block? So these 3 records saved in the block: first 4, 5, 6, 4, 5, 6 saved in the second block. Third block we have 7, 8, 9, and fourth block we have only 10 records. So as you can see that we have a 4 block created. In every block we have a 3 records. So first block having a 1, 2, 3, 3 basically 3 records. Block second having a 3 record, block third having a 3 record, and block 4 having only 1 record. And at a time there are multiple threads available in your machine. So, or we can say in Mule runtime. Mule runtime use multiple thread. Use a multiple threads. It can be any number based on your basically CPU or core size. Okay, so if for example if you have a 18 thread available, then your 18 thread will pick one record from each block. So that's why you're getting first first time you're getting first, fourth, 7 and 8 record process parallel. PAR parallel. And second time if you check that, then second, fifth and 8 process, and third time third, 6, 9 process. So let me show you. So I am going to clear log. I am going to hit again record numbers. So as you can see that first time fourth these 4 record process, second time these second, fifth, 8 record process, third time 3, 6, 9 record process, as you can see in the notepad also. First time, second time and third time. So based on the number of blocks, the parallelism we can achieve that there are number of thread will pick up one record at a time from one block. So if there is a multiple block, then every block we will have a multiple records process. So as you can see that at a time we process a 4 record, then another time we have processed as 2, 5, 8 record. So this is how we have processed. But use case number 6, if you say that in use case number 6 we have only 5 record and block size is 100, then only number of thread is only taking one record at a time in one block. Okay, if you have multiple block, then thread will taking one records from multiple blocks. That's why we have a parallelism achieved. Okay, so let me show you use case number 8. So use case number 8, we have 100 records and block size is second. Basically block size is 2. What does it mean? One block having 2 records. So we will have a 50 blocks and every block having 2 records. Okay, so why this example is all about, because I want to show you that how many threads I have to process records from blocks. So let me send this use case. So as you can see that first time I process these many records. So as you can see that threads is coming from overpool and the max thread count is 18. So based on my CPU, based on my code, I have 18 thread which process my record parallelly. As you can see that the 50 block is created. I have a greater than block than my threads. For example, thread count is 18, but I have a 50 block. But it is a kind of max limit for my threads. That's why at a time I can achieve 18 record can process at the same time. Another time, as you can see that another 18 record will be processed. So based on your number of thread, you can process multiple records. Yeah, and how exactly I'm able to see that? Because I have put block size is very low, because one block having only 2 records and I am providing 100 record, so that my 50 block is created, but max thread are only 18 in my basically in my machine. That's why although we have a more than number of blocks which number of thread can pick up records from block, but there are only 18 thread available in my machine. So that's why a number of 18 record I can process parallelly. Let me send you again to show you. For example, yes, this is process. Second time it processed 32. Let me show you till 32. Third time it processed those record. Fourth time it processed another 18 records. So this is how actually the block sizes work. Let me show you another example. What is seeing? So this example saying that we have Yes, we have a block size is 9, but we providing record as uh, 1 to 10. So there are only two block is created. First block having record from 1 to 9, and the second block having only one record. So let me show you that also. Okay, so it's my use case number 9. So let me show you first what is basically I have created. So I've created that number of block size is 9, and I am providing a number of record as a 10. So what, how many block is created? Only two block is created. The first block having 9 record, the second block having only one record, which is number 10 record. So my thread, so my number of thread pick up two block at a time and retrieving our records from two block as a parallel. So first, so basically basically we can say there are 1 and 10 process same time. After that they will process sequentially. So let me show you, because I have only two block is created. Two block is created, my second block having only 10 record, my other block having like 4, 5, 6, 7, 8, 9. Okay, let me show you this example. Yes, as you can see that those are processed simultaneously by thread number 30 and 2. After that we have basically sequential processing. These are the sequential processing we have. Okay, yeah. And another use case of this example is that we have a step 2. I have created also step 2. So there are multiple questions coming that batch step process record sequentially, means once the step 1 is completed, then only step 2 is executed. So answer of this question is that, so as you can see that we have a two block, one block having a 9 record, another block having a 10 record, and here my 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 one block which having only 10 record, which successfully processed. Okay, but other block having a 9 record, those are processed by one. Okay, so whose block successfully executed in step 1, and those block queued back. Basically queued back means those block will saved back into the queue. Then step second will take that block records. So what does it mean? Whosoever block successfully executed by step number 1, then it will go back to the queue, persistence queue. Then step number second will take those records from blocks. So let me show you. So in step 1, as you can see that we have a record step 1 logger, and step number 2 we have a record step 2 logger. So once this particular record step print, we got to know that that particular record successfully processed by step 2. So let me show you that. It is use case 9. So as you can see that our first and 10 record process, then step number 2, as you can see that our record number 10 successfully processed by step number 2. Yeah, and block number 1 which having 9 record is currently processing. Yes. Yes, as you can see that currently processing. My all record are successfully processed in step number 1. Then my this particular block will queued back in persistence queue. Then step number 2 will process all records from block number first, which having only 9 record. Why 9 record having on the block? Because I have defined a block size as 9. Why basically this I have said, because I want to show you that how batch step process record sequentially. So it's basically sequentially based on the block size. Once the step first executed all records in the block, then block will be saved into queue, persistence queue. Then step number second pick up record from blocks. So let me show you that architecture, which is basically let us know that. So as you can see that records processed by step one, then those record will back to queue, then by step two record, best step to pull the record from queue and process and send back to the queue. But those are not something we can talk about records. We can talk about the block. If batch step first executed all record inside one block, then that block record will process by step number second. So this is all about block size. Yes. So let me show you this third example. I have created a third example, and this is a kind of related with also block size, but it is a kind of special case when our batch job is running. Our batch job is running. At running time, uh, our system crash. So we are basically processing millions of records, and while processing, due to some system failures or due to any reason, our batch processing stop or something has happened or basically system crash. When we when we restart our system or basically when redeploy or restart our Mule runtime, then how the batch processing is resumed, that I am going to explain here. So as you can see that we have uh, records, we have from 1 to 10 record we are providing to batch processing. As of now, as you can see that the block size is 100, so only one block is created and our thread will pick record from block size, and those thread will process record at a time. What does it mean? It means that at a time only one record is processing by multiple threads. So let me deploy this third application. Yes, so my application successfully deployed. Let me send request 10, request number 10. So as you can see that I have sent request number 10, and just for basically for showing you that how exactly this is works. So that's why I basically applied a wait condition here. So as you can see that our 5 record processed, and that time our server is crashed. Okay, so as you can see that I basically stopped the record and here our record number, from record number first to 5, first to basically 6, those record are processed. Okay, and this is a kind of important that when we are going to restart our Mule runtime, so where our batch processing resume. So let me show you first basically example here. So as you know that as a part of load and dispatching phase, batch created queue in your basically system. So those queues started with bsq hyphen your basically batch job name with basically instance id. So this is a kind of file is created inside your Mule runtime. So let me show you that file. So I am going to go in my Mule plugin, my Mule runtime, then Mule, then .mule folder, and let me choose example, which example I've created. So yeah, MuleSoft batch processing third, queue store. So as you can see that this is a queue store I have. So let me verify that it is a BSQ and that your batch name with batch instance ID. So let me show you what is my batch instance ID. So my batch instance ID is ADV57110. So let me show you. It is same. So basically batch is using a persistence queue, basically persistence storage, to basically uh, in the loading phase those records are saved in the persistence queue. Let me resume my application. Let me basically restart Mule runtime. So I deploy my application again, and as you can see that we have processed record 6, till 6 we have processed record. So what will happen when when our processing resume? So as you can see that, let me just click on full screen. So as you can see that below, our block, our number of record from that one block processing again. So what does it mean? It means that the the block which currently executed, and that time the server crashed and we restarted our Mule runtime. So the number of record which saved in that particular block, that block executed again when our server is restarted. So for that, let me show you another kind of proof that how exactly it is work. So that's why I have basically created another example, and I'm providing a kind of same input, but instead of putting a block size is 100, I put block size is 9. So we have a total 10 record, block size is 9. What does it mean? It means that we have a two block, one block having 9 record, another block having a only one record, which is a 10 record. Okay, so I'm going to hit on basically I'm going to send a request on use case 11, and I will basically uh, once my record number 10 from another block is processed, then I will stop Mule runtime. Okay, so request number 11 I hit. So as you can see that this is successfully processed. Record number 10 is successfully processed. Let me stop server. Okay, so as of now, what is the situation here? The situation here is we have a two block, one block having 9 record, another block having a 10 record. From block number first, we have only processed first, second, third, but block number second we have processed 10. We have processed in record number 10, and this is the only record which is saved inside the block number second. So I'm going to show you when our server resume, the another block which we have successfully processed, this is processed again or not. So as for me, it will not process again. Only the first block is processing, because while processing that block we are getting a system crash, but our another block successfully executed which having only one record. So let me show you console. So as you can see that the block which having records from 1 to 9, it is processing again. Block which having only one record, which record number 10, is not processing again, because that block we successfully processed before system crash. So the currently the which block we are processing, that block is processing again after resume our batch processing. So yes, it is successfully printed our summary. So this is about basically the block size and the batch processing crashing and how it will be resumed. In part 2, I will basically cover my other example in part 3.